Hello student, I am Prachi. In the last lecture, I am discussed the some MCQs in the testing and troubleshooting of transformer. This is the unit number 4 in maintenance of electrical equipment. So today I will discuss the some next MCQs. Means there is a next part. This is the third part. I am also already two videos upload on these MCQs. So this is the part 3. So there are a total 14 MCQs explain, and this is the 15 number MCQs. Today I start. So this is the question. Oil is provided in an oil-filled transformer for lubrication, cooling, insulation, both cooling and insulation. Correct answer is option D, both cooling and insulation. Explanation is that transformers have broad applications for various industries. Mainly distribution transformers are filled with oil. The true primary function of the transformer oil is given below. Insulator. The transformer oil has high dielectric strength. It means it can withstand very high voltage. This is the only reason it acts as an insulator in the transformer. Second is coolant. As we know, the transformer's coil are made up of copper and carrying a very high current, so it becomes hot in a very short time. The transformer oil is a good conductor of electricity and heat, so it reduces the coil's temperature. Next question is that a Buchholz relay can be installed on oil cooled transformers, auto transformers, welding transformers, or air cooled transformers. So the correct answer is option A, that is a Buchholz relay can be installed on oil cooled transformer. Explanation is that the primary function of the Buchholz relay is the detection of arcing in oil cooled power transformers. The arcing emits gases that travel on the top of the tank head and increases the pressure over there that starts the relay. Next question is the noise of the transformer primarily due to. Correct answer is option C, that is the magnetostriction in an iron core. And the explanation is that the noise of the transformer, also called humming, is mainly due to two reasons. First is the magnetostriction. Magnetostriction refers to the expansion and contraction of the laminations due to the magnetic effect of the current flowing the coil of the transformer. Magnetostriction may be controlled, but it can be totally removed depending on the transformer's design. Coil of the transformer. Magnetostriction may be controlled, but it can't be totally removed. It is repeated. Stay magnetic field. Generally, the steel used in this transformer core and wire used in the transformer coil vibrating at 50 Hz to 60 Hz frequency because of the interaction of the magnetic field. Next is, if a transformer is connected to a direct current supply, what happened? Means transformer is connected, it's always AC, but it is connected to DC supply, then what happened? Correct answer is option A, that is the damage the transformer. Means transformer is connected to DC, then damage the transformer. Explanation is that, as we know, a transformer works on the principle of mutual induction, where you need a dynamic magnetic field to generate and induce EMF in the secondary winding in direct current supply. The change in frequency with respect to time is null, which means the DC supply can't produce a dynamic magnetic field. Hence, mutual induction can't be possible on direct current supply, since the primary winding of the transformer has a very low value of resistance, so it cannot oppose the excessive flow of current. Therefore, the current having high value can damage the winding. Next is cruciform shape is used in the transformer core too. Correct answer is all of the above, means reduce core reluctance, reduce core loss, reduce copper loss. Explanation is that cruciform shape is used in transformer core to reduce core loss, copper in the winding, reduce core reluctance and reduction of iron and copper loss. In the transformer, eddy current loss in the iron core are directly proportional to the core's thickness. To reduce eddy current loss, we usually use thin sheets of the iron core to reduce skin effect. Next is, which of the following does not change in an ordinary transformers? So the correct answer is option B, frequency. Means frequency is always constant in the transformer. Explanation is that the transformer is a static device, so the rate of magnetic flux change is constant for a certain operation. The moving flux in the transformer core is caused by the coil, whose frequency is controlled by the primary supply. Since the coil or stationary conductors are static, the frequency does not change. The dielectric strength of transformer oil is expected to be. Correct answer is option B, that is the 33 kilovolt. So the explanation is that the dielectric strength refers to the withstand value. It means the electrical stress which oil can withstand safely. Usually we monitored in transform oil is breakdown voltage, the maximum electrical stress on which the transformer oil breaks down. These MCQs are very important for the exam. So listen carefully. In the transformer, the function of a conservator is to. Correct answer is option A, that is the protect the transformer from damage when oil expands due to heating. Explanation is that in the transformer, the conservator provides free space for the expansion of the oil. When the transformer is on full load, the oil heats up and expands. When the load is reduced from the transformer, oil temperature shrinks and oil contracts. Here the airspace in the conservator enables breathing when oil expands or contracts. It is possible to manufacture a transformer without a conservator, but in that particular case, a tank with a gas cushion is required at the top of the transformer. So the some MCQs we will discuss in the next video. So today's thank you for watching our channel.